In this video, we will discuss measurement levels or measurement scales of variables. This is another important aspect to be considered when dealing with data. Based on this measurement level, we decide the tools to be used for analysis. Generally, measurement levels are decided based on the type of variables. Qualitative variables are measured either on nominal scale or on ordinal scale. If the data generated by a variable represent distinct categories without any inherent order, the measurement level is nominal. On the other hand, if the data generated by a variable represent categories that can be ordered according to some priority, the measurement scale is ordinal. Numerical variables are measured either on interval scale or on ratio scale. The distinction between the two depends on the nature of zero. If zero is relative and does not represent the absence of an attribute, the measurement level is interval. On the other hand, if the zero is absolute and represents the absence of the attribute, the measurement level is ratio. I can make more clarity on this by taking examples. Examples for nominal variables are gender, religion, eye color, etc. On the other hand, in a consumer perception survey, if the consumers are asked to rate a product excellent, good, and poor, it would be considered as ordinal scale. Similarly, student grades, priority values, etc. are ordinal. Temperature and time are typical examples of interval scales. For instance, when we say temperature is 0 degrees Celsius, it represents a relative position. And 0 degree Fahrenheit is another relative position only. They do not indicate the absence of temperature. The same is applicable to time. In this case, interval between two numbers is meaningful. The elapsed time between 3 am and 6 am is same as the elapsed time between 5 am and 8 am. That is, interval is meaningful, but ratio is not meaningful here. We cannot say 8 am is twice as long as 4 am. Any physical dimensions such as height, weight, area, income, revenue, etc. are examples of ratio variables. In this case, 0 indicate the absence of the attribute. For example, when we say income is 0, that represents there is no income at all. Similarly, when we say the revenue was 0, that represents there was no revenue during that period. In this situation, ratio between the two numbers becomes meaningful. For example, weight of 8 kg is twice as heavy as weight of 4 kg. Next, we will conclude this video by defining certain technical terms associated with data collection. The first term is population. A population is the set of all items or individuals of interest in a study, and the size of population is denoted by capital letter M. Whereas a sample is a subset of the population that contains only a portion of population from where the investigator is planned to collect data. The size of a sample is usually denoted by small letter m. The next term is parameter. Any summary measure calculated using all population values is called parameter, while any summary measure calculated from the sample values is known as statistic. For example, suppose we are planning to conduct a survey on the students studying in a university. The set of all students registered in the university for various courses is the population in this case. We can collect the list of all registered students from the university, and suppose we select a set of students from the list for collecting information. This subset is called a sample. The average expenditure of a student calculated from the population values is called a parameter. but the average expenditure of a student calculated from the sample values is a statistic. At this point, I have to make certain remarks. A population is hard to observe and hard to contact, whereas sample is easy to observe and easy to contact. This is the reason why statistical analysis are mainly based on samples. A sample should possess two properties, randomness and representativeness. A sample becomes random when each member of the sample is chosen from the population strictly by chance, so that every member of the population will have equal chance of getting involved in the sample. Similarly, a sample becomes representative if it is a subset of the population which accurately reflects the properties of the population. In our example, suppose we decide to walk into the canteen of the university and choose 50 students from the canteen as a sample. We have violated both randomness and representativeness. Next, we will discuss types of data. Univariate data. A data having only one column obtained by measuring a single variable is called a univariate data. A data having two columns obtained by measuring two variables is called bivariate data. Similarly, data obtained by measuring more than two variables is called multivariate data. Finally, the last point is census and sample survey. Data can be collected either from the population or from a sample. If you are collecting data from a population, it is called census survey. If you are collecting data from a sample, it is called sample survey. Census procedure is time consuming and expensive. Hence, in statistics, we prefer sample surveys. With this background, we will proceed to descriptive statistics in the next video. Thank you.